All right, the name of this section is slopes and velocities, and what we're really going to be doing is getting an intro to some of the ideas that we're going to be looking at for the next couple weeks. In other words, a lot of the things that we will do in the next couple weeks build off of these ideas. Okay, and let's go ahead and start off here with a secant line. Okay, so in this picture here, you see some curve, the blue curve here, and then you have what is the secant line here in red. Maybe I'll okay, and that's what was supposed to go here. This a line joining 2 points on a curve is called a secant line. Okay, and similarly over here is what we have below is a tangent line, but we don't quite have what we need in order to formally define the tangent line yet. Okay, so for now is what we're going to say is the tangent line is a line that just touches the curve. Okay, and by just touches I mean at the point where they intersect, they're essentially heading in the same direction, or they have the same slope. Even though it doesn't quite make sense to talk about slope on a curve, that's essentially what's going on here. Let's go ahead and move down, and what we're going to do is we're going to find the secant line through a bunch of different points, but we're going to observe what happens to these secant lines as we narrow our interval. Okay. But the thing that I do want us to see has to do something with this tangent line. So I'm going to go ahead and write down this tangent line's equation. So it's y equals 7x minus 11. Okay. All right, so next question here, or first example. Find the equation of the secant line through 1 f of 1 and 2 f of 2. So this is actually the one that's graphed up here. Okay. We're going to compute other ones that aren't graphed in front of us at the moment, but let's start off with that one. So the first thing I want you to know is that 1 f of 1 is really 1 comma 0 if you look up at the graph, or if you just plug 1 into this function f here. And this 2 comma f of 2 is really 2 comma 3. Okay, and if I scoot this up a smidge, you can see it. This other point up here is 2 comma 3. Okay, and so using these two things, we can actually find our slope, change in y over change in x. And so this just gives us a slope of 3. Okay, and then the next thing, and I'm going to use the point slope form of the equation of a line. So let's do y minus y1, where y1 is 0, is equal to m, our slope, times x minus x1. And x1 would be this point. Okay, now do note, I didn't have to use this 1 comma 0, I could have used the 2 comma 3, and we'd still end up with the same answer once we solve for y. And so let's just go ahead and distribute the 3 and then we'll be done. All right, let's go ahead and move on to the next one. And for the rest of these, I'm just going to go ahead and write down the equation or the approximate equation, but you can verify as many of these as you would like. But I don't want to waste too much of your time finding the equation of secant lines. Okay. So our next one is going to wind up being y equals 4.75x minus 6.5. Okay, so it's changed a little bit now that we've shortened up that interval. We were going from 1 to 2, and now we're going 1.5 to 2. But let's shorten it up even more. On the next page, we'll do 1.9 to 2, and then 1.99 to 2, and so on. Okay. Let's see what happens here. Okay. So the next one, I actually rounded it a little bit. Normally, if I were doing this, I would probably leave everything in fraction form. That way everything's exact. But really, for our purposes here, we're going to just want to graph these secant lines. And as long as they're approximate or close, that's all that's going to matter here. Okay, so I have y equals, or is approximately equal to 6.51x minus 10.02. Okay. And then we're going to shorten up that interval again a little bit more. We're going to do that really 2 more times. And so the next one is 6.95x minus 10.9. And then the very last one, going from 1.999 to 2, the secant line is y is approximately equal to 6.995x minus 10.99. And so now I want you to think for a second, if it looks like we're approaching a certain number, okay? Maybe that m and b seem to be approaching a certain number as we get closer and closer to 2. Okay. But I actually want us to go ahead and look at all this graphically. So that's what we're going to do here next. All right, let's go ahead and try out part F here now. And all I want us to do is graph the function, its tangent line, and then all these secant lines. And is what we're going to be looking at is what happens to these secant lines as this interval gets smaller and smaller. Okay, and by interval, I mean the smallest one for us right now was x equals 1.999 to x equals 2. Pretty small interval. Okay, so let's take a look. Okay, so if I zoom out a little bit here, we should be able to tell. There it is. This is that same curve F. The blue dot is where our tangent line goes through the curve. Okay. And is what we should see here as we slowly hit some of these secant lines is that the secant lines are going to get closer and closer to becoming the tangent line. Okay, so you can see here, here's our first secant line here in purple. Okay, and you can see it actually goes through the blue curve twice. Okay, so we know it's a secant line if it goes through twice. Okay, let's go ahead and click the next one. The next one should look like it's closer to the tangent line. It should be a little bit steeper. Okay, and so you can see it is. It's even closer. Okay, and honestly, these next two are almost indistinguishable from the tangent line. Okay, I'll just get rid of these other two, and let's do the very last one. Okay, so if I zoom in, and I'm even going to get rid of the curve. Okay, if we zoom in, we'll be able to see that we do have actually 2 different lines here. Just might take us a little while. Okay, so yeah, very, very close together here. Now that we've seen what's going on here geometrically, let's answer part G. As A approaches 2, what happens to the equation of the secant line through A comma f of A and 2 comma f of 2? Okay, so again, it really is what we're talking about here is shortening up that interval, finding the secant line between 2 points that are really close. Okay, so when that happens, what I'm going to write here is going to be fairly informal, but the equation of the secant lines approach the equation of the tangent line. Okay, and the thing that's actually more important here is that the slope of the secant lines is approaching the slope of the tangent line, but we'll talk about that more in the following pages. All right, now we're going to go on to another topic which at first might feel unrelated, but we'll see that there's a connection here between what we just did and this new topic. But this new topic here is velocity, and this is really just talking about speed, but we're giving it a direction. Okay. For any of you who know what vectors are, vectors allow us to describe quantities, but also give a direction to them. Okay. So maybe we have a force, and that force is being applied at an angle of 45 degrees off the horizontal. Okay. Now, let's see here with velocity. Velocity is a vector quantity. It is described by using speed and direction. Okay. Now, we're going to stick with one-dimensional motion for now. Okay. And so what that means is our direction is just going to be given by the sign. Okay, so if it's positive or negative, it's going to indicate what direction we're headed. Okay, and we still typically denote, or we will typically denote velocity functions by v of t. Okay, so you'll probably have quite a few homework questions where you'll see v of t, and it's going to be it'll represent a velocity function. Okay. Now, I said that we're going to be looking at velocity in one dimension here, okay, so along an axis, and so that could either be happening up and down or left and right, okay, and we're going to take the convention that if the velocity is positive, the object is moving up. That is, if we're talking about vertical motion, up and down motion, and if the velocity is negative, the object is moving down. Okay. And then if we're talking about left to right, then we'll say if the velocity is greater than 0, the object is moving to the left. To the right. There we go. And if the velocity is negative, then the object is moving to the left.